So in this tutorial, I'll be talking about the threading module in Python. Okay, so as you might know, Python is actually a slower language compared to other languages like C and C++. So in order to make it faster, or in order to make Python faster, we have a lot of ways, and one such method is threading. So we can use threadings to actually speed up our code. So I have a program here. It is just a small 15 line of code here. So this is actually a simple program. So I have two variables called start and finish. This actually basically calculates the start time, and this calculates the finish time. So, and at the end we actually print the difference between them, so we actually know how much time our code took to actually get completed. So and we also have a function here. So it's actually a simple function. What it does is that it actually says sleeping for 1 second, and then it actually sleeps for a second, and then it actually prints done sleeping. So now if I just execute this program, or if I run this program, I get okay, this function get executed. So, and it actually got finished in 1 second. And now if I just run this program twice, and if I just run the program, we actually took 2 seconds to complete, and that makes sense, right? Because this function took 1 second, and when we actually executed it twice, it actually took twice the amount of time. So I have a illustration of how this works here. It's actually a nice resource that I downloaded from the internet. So it's actually a nice illustration. So what it does is this is actually a demonstration of what we actually did. So this is the function, this is the first function. uh, when we executed it, it actually slept for a 1 second, or it actually sleeps for a second, and then the second function got executed, which also sleeps for a second, and we were done. And so that is what it actually does here. So 1 second plus 1 second, so it actually takes 2 seconds. And that is how this thing works. So what you need to understand is there are two types of tasks here. So one is CPU bound task, and other is IO bound task. So CPU bound task means it actually uses CPU, or it is actually doing some calculation in the background, not simply waiting, or it is actually using the CPU in general. So it is actually using the hardware. But IO bound task means it's actually simply waiting to get user input or some kind of response from somewhere. It is not really using CPU that much, and it's just simply waiting. So for automating, or for actually speeding up such kind of tasks, I mean for actually speeding up IO bound tasks, we can actually use threading. So uh, so I have another graph here, or another illustration here. So this is an illustration for IO bound task. So what it actually does is it actually executes the first function, and the first function actually starts sleeping for 1 second. So while we are actually not doing anything, so now we are actually not doing anything, so we are simply sleeping. So the second function actually get executed, and meanwhile the first function completes, and together both of them get completed, and it is done here. So we get an illusion of actually uh, speeding up code, or we actually get an illusion of running multiple tasks at the same time, while it is not actually doing it. For really actually executing multiple tasks at the same time, we have to use multiprocessing, but threading can actually speed up code in some cases, but in most cases you will have to actually use multiprocessing. We'll discuss about that later. So yeah, let's discuss about threading now. So I'll actually explain it one last time. So while we actually wait to receive some inputs, or while we actually simply waiting, while we are actually doing some waiting, or some sleeps, or we are doing things like that, we can actually run other code at that time, and in that way we can actually speed up the program a bit. So that is everything about uh, threading in Python. So I mean, that is a theory. Now let's just look at the practicals. So So now let's see how to actually use threads in this case. So threading is actually an inbuilt standard Python library, so we can simply import it. We can import threading, and we can actually create, or we don't actually need that anymore. So now let's just create a variable called t1, and we'll say t1 is equal to threading dot thread, and inside that we'll have to pass the function that we actually want to execute. So we'll say target function, which is do. We don't have to actually execute it, we simply need to just pass that function. And now we'll just we'll actually do two things. So we'll execute that same function twice. So we'll execute it, we'll pass the same function, target is equal to do. So now let's just see what if. Okay, so the program didn't run, or we actually didn't execute the function. To actually execute it, we have to say t1 dot start, and we have to say t2 dot start. And if we just run the program, okay, let's see what happened here. So it actually said, so let's see what has happened here. So it said sleeping for 1 second, and then actually without sleeping for this so it actually said sleeping for 1 second, and then it actually sleeps for 1 second, and while that it was actually sleeping, the program or the thread actually ran further, and it actually executed the t2 thing, or the t2 thread. And while it was I mean while the first function, or first t1 was actually executed, it actually sleeps for a second, and at that time, at that 1 second lag, t2 got executed, and so it actually prints sleeping for 1 second the second time. And that was also over, and it actually went to here, so it actually prints finished in 0.001 second. It actually took maybe 1 or 2 seconds, but it is actually printing 0.001 second, because only after that it was done sleeping. So it may have taken 1 second, or a little bit more than a second, but it has actually printed out only 0 second here. So this shouldn't actually happen. This should only be printed after executing all these threads only. So in order to actually make sure that we complete all the threads before actually printing this thing out, we can use the join method. So I'll just have to say t1 dot join, and then t2 dot join. So yeah, now this will actually ensure that all these threads are completed before actually printing out the finish time. So now if I just rerun the program, okay, so now it actually prints sleeping for a second. So when it actually sleeps for a second, while it is actually sleeping, the t2 get executed. So the function runs again, and it actually prints sleeping for 1 second again, and then both of them actually finish this, and they print done sleeping. So earlier it actually used to take us 2 seconds to actually run this function twice, but now with threads we are actually doing it in half the amount of time. So the more tasks we have, the faster the threads are going to be, or the faster the threads are going to be. So let's actually try to execute this using a for loop. Let's actually try to execute multiple things. Now actually let's create more threads, and we actually created 2 threads, and we actually ran it, and we actually were able to do something that usually takes 2 seconds in just 1 second. So now let's add more threads, and let's see how much speed up we can actually get. So say I want to make maybe 10 threads, so I can maybe say t1 t2 3 t3 up to t10, and that's definitely going to be fine, but that's not a good practice. So let's use for loops here. So okay, so let's remove this. We don't need any of this. Okay, we'll just copy this one. That is what we only need. Everything else is going down. So now let's create a loop. We'll say for underscore in range of 10. And if you are not sure what this underscore here is, it is just a throwaway variable. So what I mean is I just need to loop over this thing. I just need to loop. I don't need a variable here. For example, if I say I here, I need to actually use that I for something. So the variable we are going to declare here are going to be of no use. So we are not going to declare a variable here. So we say underscore, and which means it's actually a throwaway variable, or we are actually not going to use it really. So we'll say t is equal to, and we'll say we'll paste that thing threading.thread target is equal to do, and we will actually start the thread. We cannot actually use a join method here because we need it to actually execute after completing the thread. So we cannot do this because it will be executed each time before a new thread is being executed. So we need to actually remove this from here. So what we are going to do is we are going to do something. So we'll actually declare a list here called threads and set it to an empty list, and we'll append this. So we'll just say threads, dot append, and we'll just append this t. We'll append this thread to that list, and so we'll append this we'll append t to this list. So now after that we'll have to iterate over the list, and we have to say for thread in thread dot join. So what we are actually doing here is we are starting our loop, or we are actually starting our thread using one loop, and then we are actually looping over those threads again, and then applying the thread dot join method there. So we are applying the dot join method to all those threads in a separate loop. So if we just simply apply this dot join method here, it's gonna run synchronously. So it's not the way we actually want it to run. So we have to use this method here. So now if we just run this program, okay, so yeah, it printed 10 times and it was actually finished in 1 seconds, so 1.002 seconds. So a normal thing which could have actually taken 10 seconds now has been completed in 1 second. So you should have noticed the speed difference here. So this is why we actually use threads. So, and I am reminding you that threads are only useful for IO bound tasks, or tasks like these when we have to wait for inputs, or we are actually doing nothing. Threads help us only doing or speeding up these type of tasks. Now let's actually take a look at on how to actually add variables, or how to actually pass arguments to a function. So for example, our do function does not take any arguments. So here we are actually specifying it to sleep for 1 second. So say for example, we need to pass here the seconds manually. So instead of this predefined 1 second, we have to manually pass in the seconds. So we'll declare a variable here called seconds, and let's add an f string here, and we'll say seconds, and we have to sleep for the specified number of seconds. So yeah, so we have only modified the program a little bit. So now we can actually decide how much seconds or how many seconds we actually want to sleep. We can actually pass an argument for that. So what we actually do is we simply say args or arguments, and inside this we have to pass the arguments inside a list. So I can maybe say 2 here or whatever I want to. Okay, so now we have actually passed the arguments. We have to pass it inside a list here. So say we have a multiple arguments, we can actually put a comma here and pass that as well. So now we just don't need to modify anything else. We can just run the program. And yep, we actually did it in 2 seconds. So we have seen this before. I just wanted to show you how to actually pass arguments, how to pass arguments in this. So I think you got an idea now.